Is there anything more relaxing than thinking about the complex and fascinating world of black holes? Especially when they're supermassive hyperluminous radio quasars? Wait, is that just me? Hi, I'm Miranda Cosgrove. Welcome to the STEM Loft, where the landlord said it wasn't haunted and was honestly really weird about it. Okay, I can see how thinking about gravitational forces so strong that they stretch massive space objects into cosmic spaghetti might seem like the opposite of relaxing. But I think once I tell you about black holes and how awesome they are, you might change your mind. I mean, have I ever steered you wrong? First, we need to grasp the black hole basics. When a star reaches the final stages of its life, in some cases it will explode into a supernova. This burst sprinkles star matter out into space, but leaves a stellar core behind. See, when that star was alive, nuclear fusion created a consistent outward push of pressure that balanced the inward pull of gravity from the star's own mass. But once it becomes a supernova, there are no longer forces to oppose that gravity, and the star core begins to collapse on itself. And if the stellar core is large enough, it forms a black hole. The black hole is one of the universe's greatest mysteries. It has no observable surface, but is packed with so much dense matter that its gravity doesn't let anything, and I mean anything, escape, not even light. Scientists only have tools to detect photons, like light particles or radio waves out in space. So black holes can only be detected when the environment around them is affected. Objects start to warp and bend, submitting to a powerful gravitational force surrounding a seemingly imaginary sphere. One clear sign is tidal disruption. That's when a nearby star gets too close and the black hole's gravity begins to pull the outer layers of the star away, shredding it and giving off a dazzling streak of light. But black holes can also swallow up whole stars, creating a powerful jet of energy called a quasar. These cosmic streetlights have been observed in the center of distant galaxies, alongside another notable visual called an accretion disk. These rotating swirls of particles form when dust and gas fall toward its gravitational center, and are probably what you think of when you imagine that glow around a black hole. From science fiction, you may know that any object approaching a black hole behaves in strange ways that defy the normal laws of physics. Light, gravity, and even time behave with new rules. But this is real scientific theory. Imagine this. You're an astronaut tasked to be the very first human to inspect a black hole. As you leave the spacecraft to examine the black hole up close, you look down at your watch to see time ticking past at a normal speed. Miraculously, your fellow astronauts still aboard the ship can also see your watch, only they notice the clock's hands slow down as you get closer and closer to the black hole. You return to the spacecraft after what you experience is only 1 hour, though for your fellow astronauts aboard the ship, years will have passed. Next time I get ice cream, I'll be eating it near a black hole. That way I can really savor every bite. Though scientists have a firm understanding of this concept of space-time, understanding the nature of quantum space-time and gravity is an entirely different story, and our current technology isn't equipped to approach black holes. But how close is too close? The boundary around a black hole, at which point nothing can escape its gravitational pull, is called the event horizon. The more massive a black hole, the larger its event horizon will be. Now that we know the basics, how do we distinguish the different types of black holes? They're categorized by their mass. There are many different categories, but the types scientists understand the best are stellar mass and supermassive. One of the most common types is a stellar mass star, which forms if a star over 8 times the sun's mass collapses into a supernova explosion. It's estimated that in our Milky Way, there are 10 million to 1 billion stellar mass black holes, which might sound like a lot until you find out that there are an estimated 100 to 400 billion stars in our galaxy alone. Stellar black holes can weigh between a few times to 100 times the mass of our sun. For context, that's 33,000 Earths. And they can continue to gain mass when they collide with stars and other black holes. Let's move on to supermassive black holes. Nearly every sizable galaxy has a supermassive black hole at its core. The mass of these colossal entities can range from tens of thousands to billions of times that of our sun. About 27,000 light years from Earth, A supermassive black hole named Sagittarius A star sits in the center of our very own galaxy. I know Sagittariuses are known for being free-spirited, but the black hole vibe might be a little too free-spirited. What's interesting about Sagittarius A star is that it seems less luminous than other galaxies' black holes. This could mean that Sagittarius A star hasn't been actively eating up material nearby. New evidence from NASA's IXPE telescope suggests that Sagittarius A star awoke nearly 200 years ago. Based on our long-term tracking of stars orbiting Sagittarius A star, this black hole is estimated to be 4 million times more massive than our sun. And it has a radius of over 7 million miles. Okay, so Sagittarius A star is truly colossal beyond belief. But that's still nothing compared to the black hole in the center of galaxy Holmberg 15A. This big boy is at least 40 billion solar masses. Its enormous event horizon could easily swallow the orbits of all the planets in our solar system with room to spare. Holmberg 15A is so huge and massive, it defies comprehension. But it's still not the biggest black hole we know about. Say hello to Ton 618. This supermassive black hole is estimated to be at least 66 billion solar masses. And according to calculations, it may have a radius of about 128.6 billion miles. The event horizon of Ton 618 can fit 11 solar systems side by side, but it can be even larger than that. See, Ton 618 is so far away that we can only see how it looked 10 billion years ago. Black holes were pretty much unknown until the 20th century. In 1916, a German physicist used his colleague's theory of relativity to postulate that any mass could become a black hole if compressed tightly enough. Theory was the only thing keeping black holes on scientists' radar for a while. That is until 1971, when astronomers studying the constellation Cygnus noticed X-rays radiating from the direction of a bright blue star circling a mysterious dark spot. This was the first hard evidence of the existence of black holes. In 2019, we received the very first image of a black hole from the Event Horizon Telescope, which is not just one telescope, but a global network of synchronized radio observatories working together. And here it is. Since then, we've been able to use machine learning to create an even sharper image of this supermassive black hole, located in the center of galaxy M87. Not only did this historic photograph allow scientists to confirm their theories, it sparked so many opportunities for new research. Okay, you're probably wondering what would happen if you fell into a black hole. Well, you shouldn't go poking around in there, but if you're really curious, I'll tell you. Falling in, your body would experience something called a tidal force, which is a difference in gravity between 2 points. A familiar example you might know is the force of our moon on Earth's tides. See, the moon has a stronger gravitational pull on the side of the Earth it's closest to, causing the Earth to deform and stretch our liquid oceans to create changing tides. This same type of force would be applied to your body in a black hole. Remember that cosmic spaghetti I mentioned earlier? The difference of acceleration between your head and feet would be vastly different gravities, literally ripping you apart. Scientists have a very important term for this phenomenon called Spaghettification. Those scientists are learning more about these black holes every day. These massive entities will probably remain one of the greatest mysteries of the universe for a long, long time, and will continue to alter galaxies as well as our collective imagination. Now that I've convinced you of the marvels of black holes, let's all unwind and ponder these colossal cosmic entities, peacefully drifting in the vastness of space. Hey, it's Miranda Cosgrove, your favorite host of Mission Unstoppable. I'm the only host. And if you want to watch awesome STEM videos and exclusive Mission Unstoppable clips, just make sure you subscribe and hit that notification bell.